Welcome to Advanced Regular Expression Projects. In this series, we will explore complex real-world applications using regular expressions. We will focus on how regular expressions are used in complex real-world projects. Regular expressions are very useful in computer science and information technology. Regular expressions can be used to solve complex problems like data validation, log parsing, and text processing. Let's delve into some of those real-world applications. We will also explore advanced techniques and performance optimization strategies. Here we have an email validation system. The regular expression pattern for validating an email is open square bracket -z-0-9 %+ square bracket plus symbol at symbol open square bracket -z-0-9 close square bracket plus symbol / open square bracket -z close square bracket curly bracket 2 close curly bracket $. This regular expression validates email addresses, ensuring they have a proper username, domain, and top-level domain or TLD structure. Next, we have a log parser system specifically designed for Apache logs. The regular expression pattern to capture the IP address, timestamp, HTTP method, status code, and response sizes open parenthesis / S plus symbol close parenthesis / S plus symbol / S plus symbol open square bracket open parenthesis dot star question mark close parenthesis close square bracket quote open parenthesis dot star question mark close parenthesis quote /D plus symbol /D plus symbol $. Using regular expressions in Python, you can parse through logs, extract specific data, such as IP addresses and timestamps, and analyze website traffic. Below is a snippet to show the Python implementation. The Python code imports the regular expression library. It defines the pattern as shown above. Then it opens the access.log file. For each line in the file, it matches the pattern to the line. If there is a match, then it groups the IP address and timestamp. Now let's discuss financial document extraction. The first regular expression for currency detection is $$ open square bracket 0-9 close square bracket curly bracket 1, 3 close curly bracket open parenthesis open square bracket 0-9 close square bracket curly bracket 3 close curly bracket close parenthesis star open parenthesis / dot open square bracket 0-9 close square bracket curly bracket 2 close curly bracket close parenthesis question mark $. This matches formatted currency amounts with an optional $sign and commas. The second regular expression is for invoice number pattern. It is $inv open square bracket 0-9 close square bracket curly bracket 4 close curly bracket open square bracket -z close square bracket curly bracket 2 close curly bracket open square bracket 0-9 close square bracket curly bracket 3 close curly bracket $. This extracts standardized invoice numbers with a prefix and validation codes. Here we're building a text sanitization engine to remove potentially harmful content from user inputs. The first regular expression pattern is for script tag removal. $sign question mark script open square bracket greater than sign close square bracket star greater than sign dot star question mark less than sign / script greater than sign. This pattern will remove any script tags from the text. The Python code defines a function called remove scripts, which takes text as a parameter. Then it uses the regular expression subfunction to replace the pattern with an empty string, effectively removing all script tags. The second regular expression pattern is for special character escape. Open square bracket, less than sign, greater than sign, ampersand, quote close square bracket. The Python code defines a function called escape HTML, which takes text as a parameter. It defines a dictionary of characters to be escaped. It uses regular expression subfunction to replace the special characters with the equivalent HTML. Next, we'll explore URL router pattern matching, which is essential for web application development. The first regular expression is $//users / open parenthesis / D plus symbol close parenthesis backslash slash posts backslash slash, open parenthesis backslash d plus symbol close parenthesis dollar. This regular expression captures dynamic routes, such as user and post IDs. This is useful when building APIs. In the Python code, the route is defined as above. A sample URL is /users/123/posts/456. The code matches the route to the URL. If there is a match, then the user ID and post ID are grouped. The second regular expression is for query parameter parsing. Open square bracket question mark ampersand close square bracket, open parenthesis backslash w plus symbol close parenthesis equals sign open parenthesis caret ampersand close square bracket star. This extracts parameters and values from a query string, which is important for handling user inputs in web applications. In the Python implementation, the code defines a function called parse parameters which takes the query string as a parameter. Then the code defines the regular expression pattern as above. Then it finds all the matches in the query string. For each match, it groups the key and the value into a dictionary and returns the dictionary. Let's explore building a CSV data cleaning tool. CSV stands for comma-separated values. The first regular expression is for quoted field parser. Quote open parenthesis open square bracket caret quote close square bracket star open parenthesis quote open square bracket caret quote close square bracket star close parenthesis star close parenthesis quote. This regular expression correctly parses CSV fields that are enclosed in quotes. In the Python code, the parse quoted CSV function takes a line as a parameter and parses the fields by finding all the occurrences of the pattern in the line. The next regular expression is for whitespace cleanup. The regular expression is caret backslash s plus symbol pipe symbol backslash s plus symbol dollar pipe symbol backslash s curly bracket 2 comma close curly bracket. This removes leading, trailing, and multiple spaces. In the Python code, the clean whitespace function takes a text as a parameter. It substitutes the leading and trailing spaces with empty string, and the multiple spaces with a single space. Here we have phone number standardization. The regular expression pattern is open parenthesis backslash plus question mark 1 open square bracket hyphen dot backslash south close square bracket question mark close parenthesis question mark backslash parenthesis open square bracket 0 hyphen 9 close square bracket curly bracket 3 close curly bracket backslash parenthesis question mark open square bracket hyphen dot backslash south close square bracket question mark open parenthesis open square bracket 0 hyphen 9 close square bracket curly bracket 3 close curly bracket close parenthesis open square bracket hyphen dot backslash south close square bracket question mark open parenthesis open square bracket 0 hyphen 9 close square bracket curly bracket 4 close curly bracket close parenthesis. This pattern captures phone numbers in multiple formats and standardizes them to a consistent output. Let's create a credit card validation system. The first regular expression is for Visa card pattern caret for open square bracket 0 hyphen 9 close square bracket curly bracket 12 close curly bracket open parenthesis open square bracket 0 hyphen 9 close square bracket curly bracket 3 close curly bracket close parenthesis question mark dollar. This validates 13 or 16-digit Visa cards starting with 4. The second regular expression is for MasterCard pattern caret 5 open square bracket 1 hyphen 5 close square bracket open square bracket 0 hyphen 9 close square bracket curly bracket 14 close curly bracket dollar. This validates 16-digit MasterCard numbers starting with 51 to 55. Next, we'll see how to build an HTML tag stripper. The first regular expression pattern is for basic tag removal. Less than sign caret greater than sign star greater than sign. This removes all HTML tags from the input. In the Python code, the strip tags function takes HTML as a parameter and substitutes the pattern with an empty string. The second regular expression pattern is to preserve safe tags. Less than sign open parenthesis question mark exclamation point backslash slash question mark open parenthesis b pipe symbol I pipe symbol em pipe symbol strong close parenthesis backslash b close parenthesis caret greater than sign star greater than sign. This removes all HTML tags except the bold, italics, emphasis, and strong tags. In the Python code, the strip unsafe tags function takes HTML as a parameter and substitutes the pattern with an empty string. Here we will implement SQL injection prevention. The regular expression pattern is open parenthesis \b union \b dot star \b select \b close parenthesis pipe symbol open parenthesis \b select \b dot star \b from \b close parenthesis pipe symbol open parenthesis \b or \b dot star equals sign dot star \b or \b close parenthesis. This detects common SQL injection patterns and malicious query structures. Be careful when using regular expression for SQL injection. Regular expression is not a foolproof solution for SQL injection. It is just a tool that can be used along with other tools for preventing SQL injection. Let's summarize the best practices for using regular expressions in your projects. Some implementation guidelines are: use parameterized queries to prevent SQL injection. Test patterns thoroughly with different inputs to ensure correctness. Handle edge cases gracefully. Document regular expression patterns clearly for maintainability. And consider the performance impact of complex patterns. Some optimization tips are: compile patterns once for reuse to improve performance. Use specific quantifiers such as curly brackets instead of the dot star to reduce backtracking. Avoid catastrophic backtracking by carefully crafting the pattern. Profile complex patterns to identify performance bottlenecks. And consider alternatives to regular expressions when needed. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.